Cool, thanks for being here. The talk is titled, according to the program, Metaprogramming, Programs that Write Programs. This is the one that you expected to see? Cool. At some point it got renamed. I'm not sure when. Originally, this talk was titled Elixir in Elixir. That may look more familiar because I actually gave this talk before at ElixirConf in Orlando. It was a couple years ago. I was hoping to attend ElixirConf last year, but we had another baby. So this is our first son. We've had another one since then. We got 2 sons now. And since I've given this talk in some form before, I kind of felt like cheating to just give it again. So I thought I would engage hard mode. And instead today I'm going to give you the talk, how to give the talk, Elixir in Elixir. It's a metaprogramming talk, get it? So step 1 in giving this talk is to set up the topic. It's kind of step 1 in a lot of talks, maybe any talk. This step is all about sort of teasing your audience, capturing their attention, right? We're whetting the appetite for the audience, making sure that they're interested in what we're talking about. So you might start by saying something like, this talk is about writing Elixir in Elixir. And one of the coolest things about the Elixir language is just how much of it is implemented in Elixir itself. So if you go and read the Elixir source code, what you'll start to see is the source for the things you're doing in Elixir are actually implemented in Elixir. And this is kind of crazy, kind of cool, somewhat unique amongst programming languages. But saying things like this begs questions, right? Okay, you can say that a lot of Elixir is written in Elixir, but how much is really implemented in Elixir, right? This is what's actually interesting. We all know the answer to questions like this. It depends. Depends on how we measure this thing that we're trying to put a number to. So really what we need to figure out in order to measure that, to come up with a number for how much Elixir is implemented in Elixir, is to define what is this Elixir that we're measuring, right? So for the sake of discussion, we'll just say that Elixir is all of the basic structures of the library, the things that you use when writing Elixir code. And we'll go ahead and throw in standard library because you really can't do a whole lot with the Elixir language without the standard set of libraries that come with it. When you run super complicated mathematics against this baseline, you get a number, 78%. And this is the number that I got the first time that I gave this talk. So since then, the new measurement is 87%. Wow, Elixir is that much better now, right? It's 9% more better. That's English for you. I'm from Alabama, by the way. It's interesting when you compare this number to other languages. So I ran a similar complicated scientific formula against Ruby, and I came up with 44%. And I did it again more recently, and it's still 44%. Come on, Ruby. Elixir is clearly taking off ahead of Ruby and just making strides. Okay, these numbers, not so impressive, right? You're probably looking at me and saying, okay, great, Jay, you can use Linguist, a little Ruby gem, to count line numbers in code. Not that cool, and I would agree with you. What is really neat about the Elixir language is how much of the core constructs of the language that you use, when you go and look at the implementation, they're actually written in Elixir. So if is an example. We think of this in many languages as just like a reserved word, sort of keyword in the language. In Elixir, it's implemented as Elixir code. Def, defining functions, same thing. You can go find the implementation of def, and its implementation is in Elixir. And a lot of the operators, maybe all of the operators, are also implemented in Elixir themselves. So the pipe operator is one that we love in Elixir. And the way Elixir makes this possible is a really rich metaprogramming model. Okay, we've captured our audience's attention. All attention is on you, the speaker, now. So this is the perfect time to introduce yourself. No one knows who you are yet. Everyone's watching you. So this is where you introduce yourself, right? Maybe pitch your company a little bit too, that helps. So I'm Jay. You can find me on the internet at IamVery, GitHub, Twitter, all the things. I wouldn't be up here if it wasn't for my beautiful family. My wife is back home taking care of these kiddos. She's amazing. I'm really, really thankful for all that she does for us. And I mentioned earlier that I'm from North Alabama. This is a picture of a local industry in Alabama, apparently the Elixir bottling plant. So fun fact, Elixir has its origins in Alabama, believe it or not. I went to their website. I actually wasn't sure what this company did, so I went to their website. To say that I was underwhelmed is an understatement. Apparently it's not Elixir, and it's really bad PHP too. So I work for a company that some of you may have heard of, Stitch Fix. It's a really fantastic place to work. If you're not familiar with our product, the idea is we're a styling service. So you can go online, fill out your style profile, and we'll start sending you boxes of clothes packaged by real human beings, and you're guaranteed to love what you get. It's a wonderful place to work. We have a really fast-growing engineering team right now. We're writing a lot of Ruby, but the scale that we're operating at is really making Elixir look more and more appealing. So I'm excited about the possibilities. I've got some socks, if y'all like socks. I have some, I said y'all, did you hear that? I'm from Alabama. I also have some discount codes and stuff, so I've got things if you're interested in that. Okay, enough about me. Let's move on. Let's get to the metaprogramming of this talk. So your audience has all different backgrounds. You don't really know where your audience's experience level is. So it's a really good idea early in a talk to define some terms, kind of level set the playing field so that we're all talking with the same understanding, right? So let's start by defining metaprogramming. I think we all come from different backgrounds. We all have different ideas of what metaprogramming is. Some of us think it's a really scary thing. I had mentioned I do Ruby. I come from a Ruby background, as a lot of Elixir programmers do. And in Ruby, metaprogramming happens a lot at runtime. And because of that, it's really error prone. You have to exercise the code to know that your metaprograms are behaving correctly. And that can be really scary and really dangerous, frankly. I assert that Elixir sort of dispels this myth. The Elixir metaprogramming model is actually quite a bit simpler than what you can do in Ruby. In Elixir, it's all about code generation. That's really all metaprogramming is in Elixir. In a way, that's all Elixir itself is. So let's define it. What is metaprogramming? So to define this term, let's actually forget meta for a second and just talk about what programming is, because it's just a prefix on the word programming. So programming is just doing some work on some data, right? Here's a program. It may take a second for us all to parse the meaning of this program. No, it's very simple. There's two pieces of data, they're numbers, and then the work that we're doing on it is the function of addition, right? Mathematical function. Sometimes we don't think of this as a function, but it is. You could rewrite this program like this in some language that supports it, where you have like the arguments 4 and 2 being applied to the function plus. And in Elixir, this is in fact exactly how plus is implemented. It's just a function defined on the kernel module. We have some fancy syntactic sugar that allows us to rewrite it in this infix notation. It works all the same. So that's programming. What about meta? What does that meta prefix mean? So it's all about what the data is, right? Programming is working on data. Metaprogramming, the program itself is the data that you're working on. So it's like programming the program, hence the term metaprogramming. But in Elixir, remember, this is just about code generation, and we'll see as we go along what that means and how that's sort of realized in the Elixir language. All right, everyone's on the same level playing field. Let's introduce our first bit of Elixir metaprogramming in the form of macros and expressions. These are like the two sort of fundamental Elixir metaprogramming topics. So macros. In Elixir, macros are absolutely everywhere. Everywhere. Almost all of the code you write is involving macros. Actually, almost certainly all of the Elixir code you write is involving macros. And the reason that you might not realize this is that really good macros are kind of invisible. They sort of just blend into the background. They do their job really well. They generate the right code. They just get out of your way. They sort of become a part of the language that you're using to express the program, the intent of the program that you're writing. So here's a fairly well understood example. This is the definition of a very simple test using the EXUnit test framework. So we start by defining a module, and this all seems pretty standard stuff. When you really dig in, what you realize is every single line in this program, every single one is a macro at some level. So let's break it down. What's the data, right? What is the program that these macros are working on, transforming, generating code for? We'll step through. The first one that we run into is def module. So the def module accepts everything else here as input to it. So def module is a macro. We actually saw this in James' introduction earlier. It takes a module that's being defined and then some body that defines the module itself. Within that module, we have this use thing. This is a macro also. It's a way of extending a module's behavior with some other module. So we're saying we're using the EXUnit case module in this case. And that gives us some other macros. So by using that module, we get this test macro, and it's a way of defining tests with the EXUnit test framework. Give it a description, some test body, and then finally within that test, notice 3 levels deep in our macro calls, we have assert, which itself is a macro. And the reason assert's a macro is because it's really intelligent about what type of test you're asserting, whether you're asserting just a Boolean or some equality or something. It can give us really good feedback on our tests. Yeah, so macros are everywhere. And in general, what macros do is they take a program as input to them, and then they just spit out a new program as output. Sounds like code generation, right? Now this term program is kind of overloaded in our vocabulary. So in Elixir, when we're talking about these programs that are being transformed, we generally use the term quoted expression. We also heard James mention this earlier. And so this is like the general terminology, quoted expression, that we use to passing around programs with macros. So what's a quoted expression? It's just another phrase, right? It's not meaning anything to us quite yet. So this is a way in Elixir of expressing code as data. So it's a way of turning our code into data so that we can make some determinations about it or some transformations of it. So here's an example of a quoted expression in Elixir. This represents the expression 1 plus 2. But you can see it's in a data structure, a familiar Elixir data structure, this 3-element tuple. And what you realize as you study quoted expressions is they're a way of capturing an abstract syntax tree of your Elixir program. James really set me up well this morning because he mentioned ASTs as well. Love it. If you're not familiar with an abstract syntax tree, here's an example of one kind of plotted visually. We can walk through it and we get a prefix notation out of it if we walk kind of depth first through the syntax tree. And this prefix notation is a notation that captures precedence. So you have functions and arguments in it, but the parentheses are sort of implied. You have to perform this addition before you can perform the division. And if we rewrote it in a more familiar form, we can't, that precedence is no longer captured. We have to have parentheses to override the order of operations that mathematics give us. So prefix notation is really handy. And what you realize is it's embedded right in the syntax for a quoted expression. So quoted expressions are actually an Elixir data structure that encapsulates this prefix notation. All right, so a 3-element tuple, that's the general form for a quoted expression. Any random function call with arguments that we want to express, we can do that with a quoted expression. Great, we have the tools we need. Back to macros. So macros are just functions. Now they're special functions, I'll grant you that. We'll talk about the differences. There are kind of 2 important differences in macros and just regular old Elixir functions. One is that the arguments to macros are implicitly quoted. So that means they're converted into this abstract syntax tree whenever the macro is evaluated. So those expressions themselves are not necessarily evaluated, right? They're quoted, they're turned into that syntax, that data structure, and you can do something with it. You may return it, which makes them evaluate, or you may just throw it away. So let me show you an example to instill that. So this is a module expression that defines a macro match A. It's a predicate macro, I guess you'd call it. And the role that this function, the thing that this macro does, is just determine whether the expression passed to it is a match operation or not. Simple enough. The first one's not. Greater than is the operator, so it's false. The second one is a match, so we return true. Now the implementation of this macro is surprisingly simple. Since the expressions passed to macros are implicitly quoted, you can just pattern match on that data structure. And you can say, hey, if this the function is a match, then we return true. And for everything else, we return false. And that's the entire implementation of that macro. Pretty simple. So the second aspect of macros is that they execute at compile time. And this is really important. This is a really important part of code generation. So we take that same example and think about what happens at compile time. At compile time, this is evaluated, and whatever the return value of that macro is what is literally inserted into your code. So as far as the compiled code is concerned, it looks like the literal false and the literal true in your code. So the return value of a macro must be a quoted expression. We must return one of those abstract syntax trees. So remember, AST in, AST out, code generation. That's all macros are. Here's a really stupid example. Macro named bad match. It just generates the expression for an invalid match. The arguments to the match are lol and lat, and that's a bad match. So if we use that, like we might here, at compile time, it becomes literally the bad match. So anytime you run code that you reference that macro, you're going to get a match error. Not a good example, not a useful example, but it illustrates the fact that that macro becomes literally the code that it returns, the expression that it returns. So expressions in, expressions out. Macros generate code. All right, so this is actually all you really need to know. All your audience needs to know about macros to write them at this point. But there is a really important tool that Elixir gives us that makes writing macros much, much easier. And that is this idea of quoting. So here's an example of a slightly more complicated expression than what we've seen so far. And it's already really difficult to read. It's hard to parse out what is happening here. You might look at it for a moment and say, okay, we got 1 added to 2 minus 3. Yes, except there's precedence in there. The 2 minus 3 has to happen first, and the order of operations wouldn't capture that, so you'd have to have parentheses. So it's not as intuitive as you might think it is. So Elixir gives us this function quote to generate these expressions. It exists entirely to just make expressions easier to read and write. That's its purpose. So all quote does is return the abstract syntax tree for some expression that you give it. You can kind of think of this as being the thing that's implicitly called on the arguments to a macro, right? Arguments to macros are quoted implicitly, so it's almost like they're being sent to quote implicitly, right? So it returns these 3 element tuples. We've seen this over and over. I think it's starting to sink in. So here's an example of using quote. That's that same stupid bad match that we've been talking about. If we were to use quote to generate the expression, we'll get literally that data structure out of it. So it's pretty useful. This is pretty easy to read, but if we add a little bit more complex of an expression and quote it, we'll get a little bit more complex result, right? Now, this is hard to read, and in fact, has anybody caught the problem? It's unbalanced, and it's because it's really hard to read these expressions by hand. It's much better to use quote to generate them. It does its job really well and gets out of your way. But part of its name does sort of beg a question. Why do we call this quote? Is there some useful definition that we can attach to that? When I was first learning about it, it didn't mean much to me. I thought, okay, this is just an arbitrary word that the Elixir team picked. But there's actually some meaning in it. So I'll hopefully explain that well. When you're reading the Elixir documentation, what people like to say is you can kind of think of quoting like strings. And I thought, that's not helping. But it sort of is like strings, actually, if you think about it. So here's what I mean. This is Ruby code. I'm not sure if you recognize it as Ruby code, but it is. And this is a quoted Ruby expression, right? The expression's 1 plus 1. It's in quotes. It's a string. This is how we express Ruby code, quoted Ruby code, right? So we could take that expression and we could evaluate it, just like we would evaluate the Ruby program that's written in our file, and we get the expected output. So in Ruby, this is how we might express a quoted expression. So in Elixir, we use quote to do that. We say quote, and we give it the expression that we're wanting to quote for later execution. We could store that off in a variable and evaluate it later, and it works all the same. But there's a really important difference between the Ruby example and the Elixir example. In Elixir, you get a syntax check, and you get that syntax check when the quoted expression is produced rather than when it's run. So in Ruby, there's nothing special about strings. You're just happening to use a string to store a Ruby program. But in Elixir, we have a special mechanism for quoting programs, and that quote won't succeed if the program is not valid syntactically. In Ruby, you might not know that you have an invalid syntax until runtime, and it's even worse if it's a really complicated expression that you're producing. In fact, in Ruby, you don't see this very often. It's usually like frowned upon. If someone's using eval, they're probably doing it wrong. In Elixir, this is like bread and butter stuff. This is stuff we do every day. So the important bit there is Elixir gives you a syntax check at the time the quote is produced, the expression is produced, rather than when it's run. So one more important thing about quote is it is a recursive algorithm. And when you're producing an expression, these expressions can be nested deeply with a number of function calls that depend on one another. And that recursive nature kind of requires we have some terminal values, right? We have to know when to stop recursing on the code that we're producing syntax trees for. And these terminal values they sort of come up in the form of what we call literals. They're values that when quoted, they just return themselves. So to kind of seal this whole discussion of quote, these are the terminal values. We have strings or binaries, atoms, numbers, lists of these things that are literals. I find it really interesting that the 2-element tuple is special. The 2-element tuple is considered a literal, a quoted literal, as opposed to 1 and 3+ element tuples. They're not literals. They'll come out in that 3-element tuple syntax. But the 2-element is special because the Elixir team wanted keyword lists to also be considered quoted literals. And if you know anything about keyword lists, they're just lists of 2-element tuples. So I thought that was pretty interesting. There's also like Booleans. You might not realize that this list includes Booleans because Booleans behind the scenes are just atoms. So nil as well. So all atoms, all these things are literals. When you quote them, they just return themselves. You have some bright audience members, no doubt. These audience members, they know about quoting. They know about unquoting. Frankly, unquoting is a little harder to get your head around. But the idea here for your audience is you can produce syntax trees, but you're not really able to modify them when they're being produced. They're just sort of literally hard-coded. It's like writing a dynamic string without the ability to stick values in it. So unquoting is all about value injection. And not surprisingly, Elixir gives us this in the form of a function named unquote. Now remember that string analogy that we talked about? The idea that quoting is kind of like strings, very kind of. You can think of unquoting as kind of like string interpolation, right? If it's value injection, it's sort of like that. So what's string interpolation? It's just about injecting a value into a quoted string. So have an example like this where some string is bound to a variable name, and then we produce a new string, and within that string we reference name. Now unsurprisingly, the value bound to name is not inserted into that string, right? Because name in this context is quoted. It's inside of the quotes. It doesn't know that it's supposed to be evaluated. So in order to tell the string quoting mechanism, like, hey, evaluate this bit of code, we use string interpolation. We say, hey, a quoting mechanism, pause for a second. I've got some expression that I want you to evaluate and stick the return value in the string. And this is how we do it. I think we're pretty used to string interpolation. So unquoting is actually just like this for quoted expressions. It's all about injecting values into a quoted expression. Okay? Here's an example. Apologies, I think the code's a little bit small, but hopefully everybody can see it. So here we're producing the expression of 1 plus num, some value num. And if you can see, the expression that's produced is actually 1 plus the variable num rather than the value. The value is not being injected. It's just like that string, right? It was hi name, not hi whatever was the value within name. And so when we evaluate this, we actually get an error. That might be a little bit surprising to some, but in Elixir, in order to evaluate a quoted expression, you have to provide the context that you're evaluating it in, and we don't provide context for this num variable, so it can't evaluate successfully. It doesn't know what num is. What we meant to do is we meant to produce the expression 1 plus the value within this num variable. And to do that, we just say unquote. So we start quoting, and then at a certain point, when we want to inject that value, we say unquote, evaluate expression and stick it within. And you can see the expression produced is that 1 plus 42. And when you evaluate it, you get the expected result. Just one more example to kind of close this off is back to Ruby, right? If we were producing a Ruby expression for 1 plus the value in num, you would use string interpolation to do that, right? We would say, hey, expression, we're saying 1 plus this thing, inject the value of num in that string, in that quoted expression, and then evaluate it, and we get the number expected. So unquote is just about injecting values into quoted expressions. There is one other important case for unquote where this is where it really started blowing my mind, is what if the thing that we're injecting is already quoted? All right, what if we're trying to inject a quoted expression into a new expression that we're producing? Like, how does that work? So this is about expression injection. It's a fun one to say. So here's a couple examples to tie that off, and this actually becomes more applicable as we write macros, which we'll see in a little bit. And we produce two expressions here, one for the expression 1 plus 1, and the second one for the expression 2 plus 2. And then we are producing a third expression that is the sum of those two expressions. And what you see in the syntax tree produced is you actually get those expressions like injected directly into the syntax tree that's being produced. You get 1 plus 1 here on line 2, and 2 plus 2 on the second line there, and then the whole thing, those two are arguments to the plus function. So it really just injects the expressions directly within the new expression that you're producing. You evaluate it, you get the expected answer. Nice. Your audience has really learned a lot at this point. They really have all the tools they need to write their own macros. And it's really tempting as a presenter at this point to kind of come up with something crazy, make them laugh, right? But I would assert that it's not a great idea when learning to try to come up with something just really silly and difficult to understand. Really, to emphasize learning, you kind of want to focus on a concept that you all know, you're all familiar with already. So let's stick with something that I think we're all pretty familiar with the semantics of. Let's just implement if. It's a pretty common example. For those of you who are not familiar with if, it works like this. You give it a condition at the top, and you have cases for whether that condition evaluates to a truthy or falsy value. At first, this doesn't really look like a function call, if. I said that if is just a function earlier in the talk. It doesn't really look like that, but it's just syntactic sugar that lets us write the if call in this sort of block format. We could rewrite it like this. And now it's starting to look much more like a function. And in fact, there's one more bit of sugar that lets us drop those square brackets off of the end of an argument list, or an argument list that ends in a list, a keyword list. And what you see is if is just a function of two arguments. The first argument is the condition, and the second argument is this keyword list that we're pattern matching out the condition, the cases that are executed based on the value of that condition. And what if really encapsulates is this idea of like truthy and falsy values. So without if, there's really not an idea of truthiness and falsiness in Elixir. It's a way of testing truthiness and falsiness. Falsiness is like any value that's literally false or nil. Elixir sort of inherits this semantic, I think, from Ruby, maybe other languages. And truthiness is just anything else. So if the value is not literally false or literally nil, it's considered truthy. So all numbers, all atoms, all those things are considered truthy. So with that knowledge, we can think of a case statement that has the same behavior as the if macro that we're used to using. The condition goes right here at the top of the case statement. And then whenever that condition evaluates to a value that's either false or nil, we execute the false case, and otherwise it's something truthy, so we execute the true case. We have those two cases. So let's just take that case statement and stick it in a macro, right? We define a macro if. Here at the top, we have the condition. We pattern match out the two cases, the do and else. And then we just use a quote to generate the case statement. So this is where unquote comes into play, right? We're generating a case statement, but we're wanting to inject the condition in that case statement. So here at the top, we unquote the condition. And then down below, we unquote to inject each of the cases, the false case and the true case. And that's it. That's the implementation of if. It's not perfect. I will grant you, the keen observer will know that this is not entirely if, but it's good enough. It's good enough for example. We can use it just like we would use the if macro that's built into Elixir. And at compile time, it literally becomes the case statement that we wrote. So it's indistinguishable in compiled code from us writing this case statement directly. But it's kind of nice that we don't have to write all this, right? Congratulations on writing your first macro. Well done. Nice. So you've kind of armed your audience with some really powerful knowledge at this point. Congratulations to you, speaker, for making it this far through your talk. These tools are kind of dangerous, though. Sometimes when you're talking to people about metaprogramming, I mentioned there's some fear involved early. Even people that do metaprogramming in Elixir are kind of like, be careful. These are flaming swords or something. I don't know. So this is a really good time to offer your audience some guidance. So we'll talk about when it's appropriate to use macros. Now, if you've ever talked to an Elixir programmer that's done some metaprogramming, their favorite thing to tell you is don't. Just don't use them. This is like one of the first things that it comes up in the Elixir metaprogramming book. Instead, you should just write functions, right? Here's an example of a really bad macro. So if we wanted to have a macro that adds two strings together that have numbers within them, we can convert them to integers and add it together, and we produce the expression to do that. Unnecessary. Indirection, right? Just write a function that does that if that's what you want to do. So you should always prefer direct solutions. One way to think about macros is there's a couple of different really good use cases for them. In that case, we didn't care about the program that was passed in. We didn't really care about generating a new program. It was all focused on behavior. So macros are really good when you're trying to make a decision based on the arguments passed in, based on the expression that's being passed into the macro, if you're wanting to inspect it and make some decision. An example of this is assert in the EXUnit case framework, or the EXUnit framework. The assert macro is able to produce better errors because it inspects the expression that it's making an assertion about. Another good use case for macros is if you're transforming the program in some way. So the if macro is a good example of this. We're actually transforming the program that is being written into a case statement, capturing some semantics that the user doesn't have to remember how to write perfectly every time. So by writing these direct solutions rather than macros, it's just less prone to errors. You don't have to carry around the understanding of expressions and code generation. You don't have to think about it. You just think about the program the function that you're trying to implement. So how about a use case? One of the simpler ones, this is actually one that I wasn't aware of when I started writing macros in Elixir, is you can use them for constant values. Usually this is if you want to have a separate module that just defines some constant values. You can stick them in that module and define macros. And what's nice about this is in your code, you can write these really descriptive names. So these are like conversion values. You can use really descriptive names like seconds per minute or minutes per hour or whatever. But at compile time, the literal values are inserted into your code. So you don't have any of the function call overhead. Maybe that's an optimization, probably premature, but I think it's a good use case. This is actually a lot like how C macros work, where you're just referencing some common value over and over. But I will say, if you're using constants within the same module attributes are the way to go. It may even be ways of referencing module attributes from other modules at compile time. Not sure, not going to worry about it. But you should use module attributes if you just have a constant within the module you're defining. A little bit more interesting use case, pretty common, is DSLs. I'll shamelessly lift this example from the Metaprogramming book. This is Chris McCord's Metaprogramming Elixir that I'm referencing. So the idea here is we sort of have a suite of macros that we can use to generate HTML rather than coding the HTML directly as strings. And one benefit, as silly as that might seem, there is a benefit here. The Elixir syntax actually prevents you from forgetting to close a tag, because for it to be valid Elixir, it has to be balanced, and that balancing will close tags for you. So maybe there's a benefit there. I don't think there's any libraries that are maybe doing this right now, but it's a fun example. A little bit more real example is in Phoenix, how we define routes. There's a DSL for defining routes, and what this actually does behind the scenes is it just defines a bunch of function heads, and the matching, the function call matching, is what actually routes your calls in Phoenix. But the DSL sort of lets us express our intent in a little more abstract way. Macros are really good for hiding details. So with the EXUnit test framework, you use this test macro and don't realize that behind the scenes, it's setting up functions, it's defining functions for you, it's sort of adding them to an accumulated list and shuffling the order around. And when we're writing tests, we don't want to think about that, right? We just want to write our test and let it run, because writing tests is hard enough as it is. So the test unit framework, or the EX unit framework, actually does a lot of work for us behind the scenes, and it's hidden. We don't care. This is certainly a way of reducing boilerplate, but more generally, macros are really good for language extension. And in fact, as I've said, most of Elixir is sort of a language extension. The core of Elixir is implemented in Erlang, and it's really, really small. Everything that you use is a macro. So if we wanted to define this module without macros, it would be a little bit more complicated than this. It would look something like this. So if we just said, hey, we don't want to use macros, we just want to define our modules by hand, this would be the code that you write for that module. So it's harder to read. We might be able to do something with white space. But I lied a little bit, because this dunder E and V thing at the end here is actually a macro also. So if we really didn't want to write macros, then just jot this down. This is a easy one to remember. You might want to use a clipboard tool or something to help you out there. That's silly. You can see I gave up trying to syntax highlight. I did all the syntax highlighting by hand, by the way. Not on this one. No. So if I could leave you with anything, I would say to remember that good macros are invisible. They just abstract some concept, and you'll use it, you'll get used to it, using it, and you'll sort of start to lean on it as like a mental framework for solving problems. You can think of this like the EX unit framework, and we don't really think about the metaprogram that's involved. We just want to write our tests, right? And that's really where macros shine. They get out of your way, and they help you, they give you a framework for thinking through your problem. Almost done. Don't leave yet, because very important part of your talk, ready to be presented. This is the part where you promote yourself. You cannot end a talk without promoting yourself. That's a fun fact. So I actually did blog about this a bit. You might find this a useful reference. So there's a bit.ly link for you. And I actually wasn't intending to promote myself very much. You can follow me on Twitter if you want to, ask questions, and thank you very, very much for your time. This one?
No. In section 7.
Section 7. Oh, yeah. Let's see.
When you implement if using case, you're checking for false case, but setting up routine.
Can't be. Surely I didn't make a mistake. That doesn't make any sense.
Yeah, so after that.
Yeah, that should be
Oh, all the way. This one. Yeah. Oh. This one.
Yeah, so after that,
You're right. Yeah. Because it goes, you're saying, I'm sorry, I just messed up the slide again, but you're saying this one where it transitions.
Yeah.
Nice. See, you got to be careful. I did that animation by hand. Can't you just enjoy the fact that I... Get up here. Anybody else? Any other questions? Yeah.
So I just had a question. You mentioned that the two-element tuple was considered a literal, and I just wondered, was that mentioned in the docs, or did you find that in the code versus like the three-element and one-element? That's the first thing.
I think I stumbled upon it, and I ended up, this was a couple years ago, and I ended up sending Jose a message and was like, hey, I just saw this thing. I think it's because you want keyword lists to be literals. Is that true? And he said, yes. I don't know if it's documented. If it's not, go update the docs. It's open source. It'll be your first contribution. Maybe it'll be your 10th contribution. I don't know how prolific you are, but go do it. Yeah. I don't know for sure if it's in there. It may be. There's a lot of really good docs about quote, actually, if you just go look at the quote function in the kernel module. It's great. Anything else?
One more.
Yeah.
What are some like code smells that you found to say, okay, maybe I shouldn't have done a macro here and undoing it? What are some typical code smells you've found?
Yeah, I think so. The question, if you didn't hear it, is what are some code smells that you might see that indicates a bad use of macros? I think if you look at the use case and you determine that it's not inspecting the arguments to the macro at all, or I mean, I guess that's kind of it, or it's not producing a new like an interesting program based on that at all. So like the if macro is sort of captures that semantic of truthiness and falsiness. So you can see like this is actually generating something that the user didn't know about. But the bad example that we gave, there was really no knowledge capture there. You can just pass along the values. It's not looking at the arguments. It's not doing anything with the expressions. The expressions are really just kind of getting in the way of your intent. So I think it's not a great answer, but I think the idea is to like really think about if dealing in the expressions that are being produced is adding any value or any context to to the code that the macro is used for. There may be some really good guidance in the Metaprogramming Elixir book. It's a great read if you haven't read it. It's really good. It's probably been revised since I've read it, so it's probably even better. Anybody else?
All right, thanks, Jay.
Yeah, thank you.